Assalamualaikum and salam sejahtera to Dr. Nurli binti Ismail. I am Anas Nadira binti Muhammad Majai from group 6 and section 7. Will be present about analysis the statically determinate beam. This is my group member Nur Aini Nasution, Aiman, Harib Muklis and Rovarash. For the introduction, in this project is to develop the static equilibrium equation to calculate the reaction force and the joint method to calculate the internal force in truss member in Python using a Jupyter notebook and learn to understand how it works conceptually. Okay, Python is a computer programming language that is frequently used to create website and application, automate operation, and analyze data. Python is a programming language that is open source. Python can create a broad variety of data visualization such as line and bar graph, pie chart, histogram, and 3D plot. To find the reaction force at the support, the creation of a free body diagram is the most important aspect of the solution approach for a grid body equilibrium problem. Using the joint method, it must analyze the total of force converging at a junction by resolving two equations of force equilibrium into orthogonal or mutually perpendicular direction that can elevate. There is three objectives that we get from this project. First is earning and create our pseudocode to design the program. Second, to transform the information from the flowchart to pseudocode and run the program. And the lastly is deliver a program that relevant to solve complicated issue related to the civil engineering field.
Hello everyone, my name is Rohrat son of P. Christian, metric card number CF20004. I am going to continue with the presentation of my part, which is I'm going to present you on about a flowchart of our computer programming. So the computer programming is basically a diagrammatic representation of algorithm in the computer programming. So we assign to write a computer program to calculate the reaction force at support A and to find out the support B, and also to find out the internal force in the member of truss, where the F equals to external force L1, the total length of member AB, and L2 is total length of member AC. Let's jump to the flowchart of our design. Okay, our flowchart will be begin with a terminal with the start. The next input will be the display of welcome to reaction force at calculator software by group 6, and then the display of after that the display will be shown as this the program are calculate for calculate for reaction force for every member. Uh, the next input will be the display structure stability by showing the method of m plus r equals to 2j, and will be further explain the next input where the input m is a member, input r reaction is r reaction, input j equals to joint, where need to key in the values of member reaction joint, and then the calculate will process to calculate the method calculate the m plus r equals to 2j, and once the process is done, the result will be shown on the next display, which is the stability. If the stability is shown will be shown if yes, is shown as a statically determinate, where the m plus r equals to 2j. If no, means it will show as a statically indeterminate, where the m plus r is not equals to 2j. So if statically indeterminate means the process will be moved to the before part, which is to calculate the m plus r equals to 2j. The process will be shown if the statically determinate, if the display stability shown as a no. If the display stability shown as statically determinate, yes, the next part will be shown as input the force value. The first value will be no if the f value is actually invalid, which means the f value is more than 100. So if the value is more than 100, display will be shown as enter new value of false. But if false value input false value will be shown as yes if the false value is lesser than 100 but more than and lesser than 100 and more than 0, the display will be shown as valid. Once the false value shown, the next will then the process done, the next input will be L2. The L2 will be shown as yes if L2, which is total length of member AC, if lesser than lesser than 50 and more than 0. And if the input value will be not accepted, will be no, shown as no. If the L2 value, the total length of member AC value is bigger than the 50, the display will be shown as to enter the new vertical length of member. And once the input which display valid, will be lesser than 50, the next part of the calculating will be shown, which is 1 for the input L1. The input L1, when inputting the L1, it's same as L2, but it not accepted. It is invalid value if the L1 is lesser than 20. So it will display as to enter new horizontal length of member, but it will be accepted as if L1, which is total length of member AB, is lesser than 20 but more than 0. The display will be shown as display now calculate the reaction of A, Y and BY, which is the total reaction at the point A and point B. So next part will be shown as the input of import mat. And next input will be display AX equals to F, display AY equals to F multiply with L1 divided by L2, and the display BX equals to negative AY. The next input will be input of import mat, and then import will be inputting the degrees equals to mat multiplied with degrees, AB equals to 0, AC equals to negative F in bracket F multiplied with L1 divide by L2, and the BC equals to negative F divided by mat multiplied with sine, which is a degree, and the CD equals to false, and the BD equals to 0. The next input will be displaying the the members of AB, AC, BC, and CD and BD. The next will be the using the off-page connector at 1, so to connect the flowchart portion in different pages. So the input will be shown as if AB is more than 0.1, the display will be shown as AB equals to tension. If AB is lesser than 0.1, the display will show as the AB equals to compression, has AB display if else the A display AB as neutral if AB is more than 0.1. The next part is if will be repeated for the each and every members of the truss, which is if AC equals to if AC is value is more than 0.1, the display value will be shown as AC equal to tension. If AC is lesser than 0, which is negative value, display the AC equals to compression, else AC display as AC equals to neutral. Same for the BC. If BC is more than 0.1, the BC will display BC value as tension. If BC is lesser than 0, the display BC equals to compression, as BC will be shown as BC equals to neutral. And here we'll using the off-page connector, so that the flowchart the flowchart portion will be continue with the different pages. Into the next page we'll be continuing with CD. If CD is bigger than 0.1, display CD equals to tension. If CD is lesser than 0, the display CD equals to compression, hence the CD display CD equals to neutral. This will follow by the BD also. If the BD is equals to, sorry, not equals to, more than 0.1, the display the BD equals to tension. If BD is lesser than 0, display BD value as a compression, as a BD else the BD display BD equals to neutral if the value BD is 0. The followed by the display of AB, uh, display the value of AB, AC, and print, display the print value of BC, CD, and BD. Where at this portion, the AB values display the AB value of the force of AB value inner by bracket 0 to the 2F in Kn format of AB. Same for the AC, which is in bracket 0.2 of value in Kn format AC, and display the pin BC of 0.2, sorry, not 0.2, 0.24 to force of Kn format BC. Display the pin CD of the CD member equals to 0 to 2F force member at Kn format of CD, and display the pin BD equals to 0.2 Kn format of BD. And that's how we calculate the reaction and also the force. And this is the end part. Once the end part is shown, the calculator is shown as end. This is the last one is the terminal of the ending of the calculate process. Thank you.
Hello and Assalamualaikum. My name is Haris Muklis bin Rosli and my metric number is CF200170, and I will talk about pseudocode. So the first one, of course, we need to start, and then we need to display the welcome to reaction force calculator software by G6. Next, we need to calculate the force. So by using the formula, which is M plus R equal to 2J, then we need to input the member M, R plus J. Then we need to calculate the member and display the member. If M plus R equal to J, so the structure is statically determinate. If M plus R is more than 2J, so the structure is statically determinate. Then we need to input the F value, and if F or less or equal than 100, so S is valid. If F more than 100, so we need to enter the new value of F. After that, we need to display the F value, and then we input load 2. So load 2 must be less than or equal to 50, and load 2 more than 0. So this display load 2 and input load 1. And this is all the same process until import mat. So display AX equal to F. So display AY equal F times L1 divided by load 2. So display BX. Next, we need to input import mat. So in Python, degrees is equal to mat.degrees. Then we need to input the import mat, which is AB, AC, BC, CD, and BD. After that, we need to display AB, AC, BC, CD, and BD. If AB is more than or equal to 0.1, AB is tension. If AB is less than 0.1, AB is compression. If AB is not in all of that category, so AB is neutral. So the same goes with AC, BC, AB, AC, BC, CD, and BD. After all of that is done, so we need to display AB, AC, BC, CD, and BD. And that's the end of the video code. Thank you.
Hi, Assalamualaikum. My name is Aiman bin Zabri. My matrix number is CF2093. So I'm going to start. I'm going to continue this presentation with my part in order to expose our own software that we have developed. So this is the front page of Jupyter Notebook. We use Jupyter Notebook to construct our software. As you can see at the below of the screen, we have named it as Group 6 Programming Structure Software in format of PYNB. So we proceed to our program. Alright. In order to notify the user, we have displayed the statement of welcome to reaction force calculator software by Group 6. Right. So and then we also display justify the user that the program is to calculate the reaction force of every member, right? So we straight to the point that we gonna start with determination of stability of structure. So the parameter that we need is member, reaction, and joint over here, right? Member, reaction, and joint are represented by M, R, and J. So if we click run, the first one will ask you about M. M is member. So based on the diagram given in the instruction, member is 5. The reaction based on roller and pin support is 3. And then the joint is 4 in total. Right. For the next one, the software asks about the F value. F is force. So for F value, we construct over here is uh, we must have F below than 100. Uh, if we type below from 100, they will state as valid. So if else, meaning that if over than 100, the value is they will ask the new F value, right? So we assume F value is 50 kN. We have to put the value in kilonewton. So they will ask you about the vertical length. Vertical length represented by L2. So we have set the limitation, which we must insert the value of L2 less than 50, greater than 0. So else, if you put any value else than the limitation, the software will ask you the new vertical length. So the range is between 0 to 50. So uh, we put 45, and then same as the vertical, horizontal also about length, but represented by L1. So the limitation is we have set the L1 between 0 to 20. It is because given in the instruction that L1 must not be greater than L2, right? So between 0 and 20, we can put it as 15. Right. So over here, they have calculated the reaction of AY and BY. Alright. For AY and BY, reaction of AY and BY, right, it is stated over here. Based on the data given, they has calculate the reaction, and then after the reaction, they will find the degree of AB, AC, BC, CD, and BD. We have to put the right formula, such as AB0 is because their location is at the end of the structure, and then for AC, the formula is F times L and then divided by L2, right? For the BC and CD also, they have their own formula different from AC, right? such as BC, negative F, divided by answer of mat times sin times degrees. So like shown over here, AB is neutral, AC is compression, tension, compression, neutral, right? So this one, the last one, 0 negative 16.67 is the joint force output. So we have set the statement over here to represent the joint force output, right? So if we put the correct formula, they can run until they finish the calculation. So that's all from me. Thank you.
Assalamualaikum. My name is Nuraina Stumit Usman. My number matric is CF200091. I will to continue this presentation to conclude for our presentation today. Python is a multi-paradigm programming language that supports imperative, object-oriented, and function model. Python functions are object and may be treated as such. They can in particular be supplied as parameter to other functions, sometimes known as a higher order function. Based on our study, we create a simple coding system for students to utilize in calculating the reaction force and internal force at the structure using civil engineering, static, equilibrium equation, and joint technique, respectively. We were able to save more time for the novice by utilizing this program instead of calculating the calculation manually. Not only that, but our software can assist students in determining the data required. Finally, we hope that our effort will be useful and to others to make their work easier. That's all for our group. Thank you.